All right, so today on an integration side, big push was to get the CAD completely finished for the robot. And it's pretty much 98%, maybe 100%, depending on how much we end up doing. And the robot will now look like this by tomorrow morning. There's a number of fires to put out in the terms of making sure different components we're mounting, continuing to figure out some clearance issues, and as well as putting around the different panels that we're going to hold in our balls as our hopper. If you can look from the top down, you can kind of see the space we have where this is the end of the intake plate. Ultimately, one big we're really seeing from this CAD that we kind of saw when we put the CAD together yesterday is our hopper is not going to be as big as we initially hoped it to be. Generally, we're only going to have this space around the upper part of the robot, and then all this space to hold balls in the indexing system to hold balls, which I don't know, might be, if I were to make an estimate, maybe 8 or so at a maximum. Maybe if you really pushed it and things were piling up just the right way, maybe 10. But one thing we definitely realized with this game is that optimizations to a robot, there's going to be a lot of optimizations you can do to these robots, because since you can hold as many balls as possible, there's certainly going to be so many things you can do to just increase as much space as possible. There's a lot of optimizations we could do, including dropping our indexing system down in between the chassis of the robot, which would be much easier if you had a swerve drive system. We don't, and we also don't have the time to re-engineer all of that. We could take our intake and we could push it farther out, or make it simpler, so then it would take up less space on the robot. I know that some Ri3D teams are doing an extended hopper. There are certainly a lot of different ways to optimize a robot to have more space, and ultimately we don't have enough time to do that, but we want to encourage all teams to think about that as they're making their designs. Otherwise, for full team, as people have been putting their designs together, one of the biggest things people have been doing, we've been lucky enough to have a lot of metal parts cut yesterday, and we got all our metal parts finalized today. So people have been assembling their systems independently and running them with electronics to test them. This has been very important for us to figure out that we need bigger gearboxes on our Neo 550s, on our intake, that we need to make some gear test changes with our indexing system. We made a number of modifications to our shooter after we found out that certain things wouldn't work on that. So we've been really pushing on testing systems before we get them on the robot, and that has saved us a number of times to making modifications to make these systems work better.
Today in Field World, we finished all the field elements that we were planning on building, except for one part that is currently setting and drying. But everything's done, everything's ready for the robots to play with, and we finished.
All right, so intake finished building our intake in. The spacing was originally pretty off, so we worked on fixing that, as well as gearing up the motors, the rotating motors more, so that it's able to rotate it, because we thought it needed more torque. We also added hard stops to the structure so that it has a nice place to sit, and we're also going to add support beams when we get it onto the final bottom.
All right, so for software today, it's been a relatively productive day. There's been kind of some low periods where we haven't had too much to do, but it's kind of been more of a, as mechanical comes around, we kind of get to start testing a lot of our subsystems and kind of ensuring everything works. So most of today went towards, as mechanical finished up a subsystem, we would start programming and we would start kind of measuring all of our constants and ensuring all of our logic worked. So we did that for the turret, for our indexer, and we're just about to start with the intake. So ideally the only thing, ideally we'll have everything tested because we already know that our drivetrain works. And outside of that, when robot hopefully gets put together here relatively soon, we should have a fully functioning robot. And we've got all of our vision code and everything written, or mostly written. So ideally when 6 a.m. comes around tomorrow, when mechanical should be done with the robot, we should be able to start kind of debugging and ensuring that all of the code works on our kind of final robot, and that vision can actually start to help, and more importantly, works at a basic functioning level, because it either mostly works or it doesn't at all. So so far so good. Yeah.
Hey, I'm Quentin and I'm part of the Indexer team. Today we didn't change much of the design of the index. All we changed was we made the flaps angled so that we would be able to push the balls up into the turret more easily. And then we water jet out the panels and the sides of the ramp where the balls will go up into the turret. And we 3D printed all the pieces we need, and it's currently being assembled.
Hi, I am the electrical lead, and I have two things I want to talk about. First is today the mechanical has completed sort of all of their design and started to build the whole robot, so it is sort of being passed off to me to do all of the different electrical work. So to make sure everything can be in position, we have a steel aluminum board that we're connecting everything to. So to make sure all the holes are in the right place and every mechanical bit or every electrical bit can fit, I have created this, which is an exact cutout of the board that I'm going to be attaching everything to. And basically I am designing the location of all of the different components on this. So I have the motors, these are all limitations. I can't place anything there. And it's really nice to have this physical thing because it makes sure that wires and stuff, things that you can't really account for in CAD, are physically there so you can see like what sort of space it takes up. And you can also very easily, you can figure out the position of all the holes that you need because we're just going to be drilling holes into the aluminum. Our robot also has a turret on it. So the turret has a shooter on top, and the shooter has 3 different motors. So I need to get power and signal to all of those different motors, and the turret is going to be spinning around really fast. And our goal is to make it so it can spin 360, which is going to be really rough on the wires, spinning back and forth really fast. So we have power chain, and the difficulty with power chain spinning around like that is it's going to try to constrict around the turret as it spins, and it's also going to try to bunch up in whatever corners you have. So we have designed some little plastic bits to sort of perfectly control where the chain goes, and I'm going to be testing that soon.
Alright, so I've still been working on the shooter. We made a lot of progress. The robot was 23.5, the tallest point being on the shooter. So we actually shortened our base plate gears by 1 inch so we can go under the trench. We also increased, we did everything we said we were going to in the last video. And right now we're assembling it after water jetting and printing everything to be put on the robot in probably the next like 20 minutes. We added a tensioner, and we also worked with software to test distances and different configurations to create a lookup table so we can get some nice data and accuracy there.
I'm working on the climber sub team. So today the goal was to finish the CAD and start building the elevator. And we attached to the drivetrain today, and it now is flush against the drivetrain rails. And we have a support going both direction to the drivetrain to make it more stabilized. And then we worked on the hooks.
We have 3 passive hooks that we've been working on. This hook is a stationary, the hook that's moving, and these 2 hooks, we are still debating on the design we're going to choose, but these 2 hooks are the passive hooks that are stationary. This hook bends down, and the point of the hair ties is to keep it for it to come back up, and the pivot point is for it to move around, but this hook, the pivot point is up further. I'm not going to demonstrate the hook.